So, hello everyone. My name is Ashfaq. So, my UID is roll number 22. I'm roll number 22. So, my major project title is face mask detection with deep learning and computer vision. This is my project title. So, what? So, first of all, start with the abstract. So, abstract is nothing much. So, basically, we all know that in the present situation, COVID-19 has become a pandemic and is causing a global health crisis. So, we need to So the effective protection methods is like wearing a mask in public areas according to the World WHO, that's nothing but World Health Organization. Even COVID-19 pandemic forced governments across the world to impose lockdowns to prevent virus transmission. So one of the major reports indicate that wearing face masks while at work clearly reduces the risk of transmission. So my main aim of this project is to create a hybrid model using deep and classical machine learning for face mask detection will be presented. So I will be presenting with the model. So what all we have used, I have used OpenCV library to do real-time face mask detection from a live stream via webcam. So we will use the data set to build a COVID-19 face mask detector with computer vision using Python, OpenCV, Tensor Flow, and Keras. So simple, our goal is to identify whether the person's on image or video stream is wearing a face mask or not with the help of computer vision and deep learning. So it is abstract. So let us come to the introduction. So obviously, COVID-19 is the latest epidemic virus that hit the human health in the last century. So artificial intelligence based on machine learning and deep learning can help to fight COVID in many ways. So that's our motive actually. So machine learning allows researchers and clinicians evaluate vast quantities of data to forecast the distributions of COVID-19, to serve as an early warning mechanism for potential pandemics, and to classify vulnerable populations, means who will be targeted more. So based on these things. Next, people are forced by laws to wear face masks in public in many countries. So our project aim is to monitor whether a person is wearing a face mask or not. So the process of monitoring large groups of people is becoming more difficult. The monitoring process involves the detection of anyone who is not wearing a face mask. So obviously, everyone, we cannot monitor large groups, right? So for this purpose, my project will be very beneficial. So existing system. First of all, you know what are the existing systems already available. So face detection using CNN and Gabber filters proposed by Borden Pollock. It's not face mask, it is only face detection. So used to detecting facial regions by composing a Gabber filters and a CNN. So it was used to make a use of CNN and Gabber filters for face recognition, only face recognition. CNN layer consists one of this CNN layer, the convolutional neural network will consist of one or more plane. Total 6 CNN networks used here. Next, better recognition high rate in face detection. These are some of the features of this existing system. So what is the proposed system will focus on how to identify the person on image or video streaming wearing face mask with the help of computer vision and deep learning algorithm by using OpenCV, TensorFlow, Keras, and Python library. So it was clear, simple. Because the existing system is only recognizing the face, but now the proposed system is able to also detect whether a person is wearing a mask or not. So next, literature review. So it is based upon 3 papers. So I have referred 3 base papers before going to develop this model. So one is facial mask detection using semantic segmentation 2019. So under the keywords are like fully convolutional network, semantic segmentation, face segmentation detection. So these are the things which they used in their research. Next paper is an automated system to limit COVID-19 using facial mask detection in smart cities. Okay, how it can be implemented in smart cities. It was published in the year 2020. The previous paper was 2019. So facial mask detection, deep learning, convolutional neural network, and smart city. These are the key words or key terms which they have used in their research. Next, a mask detection method for shoppers under the threat of COVID-19 coronavirus 2020. This is the third paper. Object detection, mask, feature fusion, COVID-19 spatial separable convolution. These are the things which they have inculcated or developed in their research. This is about literature review. So now, first of all, what is the main thing which main library which we are going to use in this project is on this model is OpenCV. So OpenCV is nothing but open source computer vision library. It's nothing but an open source computer vision and machine learning software library. So it will provide a common infrastructure for computer vision applications and has more than 2,500 optimized algorithms in it. These algorithms can be used to do, so there are many applications of it, like detect and recognize faces, identify objects, classify human actions in videos, track camera movements, track moving objects, extract 3D models of objects, etc. etc. There are many things, even follow eye movements, etc. So these are the some of the applications where it is mostly used, this OpenCV library. So next, what is CNN? CNN is nothing but it stands for Convolutional Neural Network, which is a specialized neural network. It comes under deep learning itself. Okay. So while we are dealing with images, we use CNN. CNNs are typically used for image detection and classification. This is all about CNN. So software requirements. So the software requirements nothing but Python has a diagram. So Python we are using it for code. Okay. It gives builds up that engages a little elements, incorporates the kind modified organization, reinforces different perfect models. Okay, it's all about Python, nothing much. So we are using also Jupyter Notebook. So for implementation, the live video, live code, etc., we're using Jupyter Notebook. So now hardware requirements. What are the hardware requirements? So basically, these are the requirements. These are the minimum requirements which are sufficient to run this project. One is RAM 4 GB, high processor, okay, Intel i3 and even above. Hard disk 10 GB, 30 to 40 channels. AI performance GPU, CPU quad cores. So at present I'm using only CPU, but to detect in live when there is a large amount of data, when large quantities of data is there, then we will require a GPU. While execution, you can see that my model gives some problems also. So the dataset collection. So the CCTV cameras are used to capture images from public places. Okay, so data from two different sources are collected for training and testing the model. So basically, we have to classify the images. Images sets into two types, into two data sets. One is 858 images of people with masks and 681 images of people without a mask. Okay, for training purposes, only 80% of the images are used for training, and remaining 20% of images are used for testing purposes. Now, image processing. So we know that while capturing a image, so it might be obviously in CCTV cameras also nowadays it's a color photo, that is RGB. So RGB color means it's a color photo. So means it consists of a higher resolution and higher size. It will be more GB. It will be requiring more GB, and also it will be consisting of more information. It's not at all required. So RGB color image stored, it will be stored at 24 bit for each pixel, right? So but we don't need that much. So grayscale, we are converting it into grayscale images, which will just occupy 8 bit, and it contains separate information for classification. Okay. So and we are also reshaping the image. The images may be of different size. So but we are reshaping it into 64 into 64 shape, so that to maintain uniformity. And it's after normalization, the value of pixel resides in the range of 0 to 1. So this is the actual thing. So now, what is the project architecture? So it consists of two phases. One is phase 1 and phase 2. Phase 1 is nothing but train face mask detector. So load face mask dataset. So in this first three steps are loading the face mask dataset. Next, training face mask classifier with Keras or Tensor Flow. Then afterwards, serializing face mask classifier to disk. So now the thing is in the disk. So what happens in phase 2? We are applying face mask detector. What happens now? It is loading the face mask classifier from the disk. Then detecting faces in image or video stream. Then extracting each face ROI. ROI is nothing but region of interest, like our eyes, nose, mouth, and everything. These are the things which is nothing but region of interest, which comes under region of interest. So applying face mask classifier to each face region of interest to determine mask or no mask. So results. So at last it will show the results in a box setting. If it is green, then he is wearing a mask. Otherwise, it is no mask, and it also shows the accuracy also. So you can see input image is in this way. So after processing, the final output will be, so if it, as in this picture, they are not wearing the mask, so it is showing red circles. This is a use case diagram. Okay, you can see there like how the algorithm is going to work. So this is the implementation. So you can see that in this picture, I myself has been sat in front of the camera, and you should make two things are very important while implementation. One is you should be a better distance from the, you should keep a good distance from the camera while it is detecting, and it should not make much disturbance while implementing this work. If it is a GPU, then you can, but in CPU, it cannot record each and every frame. So we need to be quite stable. So it is detecting, you can see that no mask. So The accuracy was 99.1%. Another important thing is it should be in bright. The light should be very bright. So if you are in the darkness, then it will not detect properly. The efficiency will be less and also accuracy comes less. And here you can say I'm wearing a mask, it's showing green. Okay, and my complete the data sets consists of a COVID, only two types of masks. So one is COVID, that is N95 mask, and this type of mask, that is surgical mask. Okay, so you better keep in mind that. So now the conclusion is nothing but, as a technology area unit blooming with rising trends, the supply thus we have got novel face mask detectors, which might pre-chance create a contribution to public trending. The structure consists of mobile net because the backbone it is used for prime and low computation eventualities. So as to extract larger strong options, we tend to utilize transfer mastering to adopt weights. So it's nothing but here we're saying that so many things can be done. Now other everything it can be also be implemented in mobiles also. So by using something called as mobile net, so we can also transfer it to mobile nets. So through mobiles also we can detect whether face mask detectors. So the main aim was simple. So nowadays, so a person cannot we cannot depend completely on man. So everyone needs to be everything should be like a person should check whether he's wearing a mask or not. So based upon this also, if we are implementing this at the cameras, installing the cameras, and the cameras will itself detect whether a person is wearing a mask or not, and it will deny the approve, means deny the entry. So that's a very thing important. So we have seen that become a standard behavior matters. So it can be a very high quality asset to the. So by the event of mask observation, we'll detect if the individual is carrying a mask and permit their entry would be of high quality asset to the society. Obviously, as to said, right? Now, if he is not wearing a mask, you don't allow them to inside the markets, everything. So the applications may be like shopping malls, colleges, wherever there are crowded places. So you don't allow them. So thank you. This is about my presentation. Now let's look into this execution part. I'll show you. So where is it? Okay. Share. So I need to on a light so that I might be visible. Okay. Execution I will on lights. Let us adjust the light here. Okay. So let us see. Okay. Where is it? Okay. So let's run the code. So it might take a while. Let's wait. So for this to implement, I should off my camera, I guess. So otherwise it won't be. So I need to off my camera. I said right. I need to off my camera. Stop share. Okay. I have off my camera. Now let's go for execution. Okay, 1 second, we'll try. So let's I think it's open. Okay. I think it has opened. So let me share my screen. So where is it? Share. So where is it actually? Right. So I need to do again. It has been some error. It's a problem. So I need to type the code once again. So Python space detect underscore mask underscore video dot py. So you need to be very patient. I said now, if it is in a GPU, then it will be very different, but it's not GPU. Once again, so it's not coming. Okay, so it has opened. So you can see that it is. So once again, we need to think. So share screen, share it. So you can see there. So I will show you the output. Where is it? Screen thing. So here you can see. So I am not wearing the mask. So it is showing no mask. So I'm using a light. So that's why it's showing 100% accuracy, 99.89 something accuracy, 100% also. So let us wear a mask and I will show whether it's detecting or not. You can see it is detecting I'm wearing a mask or not. So that's it. So this is a project. So if we are implementing it in the GPU, then it might be very useful because it requires a high bright light. The camera will be offing frequently. Stop. So right. So let's stop the execution. Okay. So that's my execution. Okay. So my camera. So that's my execution. So it's done. So thank you everyone. So I hope everyone will be wearing mask and everyone will be helping implementing this what we call the spread of pandemic. So thank you everyone. Goodbye.